So now that we proved the rule of de L'Hopital, let's take a look at a few more examples. We're going to evaluate these various limits. So first, the limit as x is approaching 1 of x squared plus x minus 2 divided by ln of x. First thing we need to do is check the assumptions to apply the rule of de L'Hopital. And in particular, we want to see if we indeed have an undetermined limit. So we plug x equal 1. At the top we get 2 minus 2, 0. At the bottom ln of 1, which is 0. So we have an undetermined form of the type 0 over 0. Therefore the rule of de L'Hopital applies. And the limit should be the same as the limit of the quotient of the derivatives. So limit of 2x plus 1 for the derivative of the top, divided by 1 over x for the derivative of the bottom. At 1, if I plug 1 in this, I get 3 at the top, 1 at the bottom, so the limit is 3. For the second one, we are seeking the limit at 0 of e to the 3t minus 1 divided by t. If I plug t equals 0, e to the 0 is 1, so I get 0 at the top, and of course 0 at the bottom. So this is again an undetermined form of the type 0 over 0, and the rule of de L'Hopital applies to the effect that the limit of the quotient of the derivatives is the same. Derivative of the top here is 3e to the 3t, derivative of the bottom is 1. When I plug t equals 0 in this, I get just 3, and this is my limit. For the third limit, when x is approaching 0, if I plug that at the top, I get 0 plus tangent 0, which is 0. At the bottom, sine 0, which is 0. So I have again an undetermined form of the type 0 over 0, and therefore the rule of de L'Hopital applies. And I get the same limit as the quotient of the derivatives. Derivative of the top is 1 plus derivative of tangent, which I can write secant squared, divided by derivative of sine, that's cosine. I plug x equals 0 in this. At the top I have 1 plus secant squared of 0, that's 1 over cosine square of 0, and cosine of 0 is 1, so I get 1 plus 1. And at the bottom I have cosine 0, so just 1. So I get 2, and this is my limit. Now I'm looking at the limit when x is approaching infinity of e to the x over x. When x goes to infinity, e to the x goes to infinity. So top and bottom go to infinity, and I have an undetermined form of the type infinity over infinity. That means I can apply the rule of de L'Hopital, get the same limit as the quotient of the derivatives. In this case, derivative of the top is just e to the x, derivative of the bottom is 1. So I get the limit at infinity of e to the x divided by 1. Since e to the x goes to infinity, this limit is infinite. Then we look at the limit when x is approaching 0 of x plus sine x divided by x plus cosine x. If I plug x equals 0, at the top I get 0 plus sine 0, so that is 0. At the bottom 0 plus cosine 0, and here you have to be careful, cosine 0 is 1. So that means we have 0 at the top, 1 at the bottom. The assumptions in the rule of de L'Hopital are not satisfied, and therefore we should not apply the rule of de L'Hopital. In fact, there is no need, because this is not undetermined limit. We have 0 at the top, 1 at the bottom. This is just 0, and this is my limit. Here you have to be careful to check that you are in a situation where you need to use the rule of de L'Hopital. Because if you go too fast and say, okay, well, this is in a list of things where I'm using the rule of de L'Hopital, and just apply it without checking, here is what you would obtain. The derivative of the top is 1 plus cosine x. The derivative of the bottom is 1 minus sine x. So if you look at the limit of the quotient of these two derivatives, you plug x equals 0 in this, at the top you get 1 plus cosine 0, that's 2. At the bottom 1 minus sine 0, that's 1, so you would get 2. And 2 is not the limit of your original expression. We've seen that the limit is 0. So you see that you would get the wrong limit applying the rule of de L'Hopital in this context. And this is because the assumptions for the rule of de L'Hopital to apply are not fulfilled in that case. Finally, I want to point out that sometimes the application is a little less straightforward. So let's consider, for instance, a limit at infinity of x squared divided by e to the x. Both top and bottom go to infinity as x goes to infinity, so this is an undetermined form of the type infinity over infinity, and therefore the rule of de L'Hopital applies, meaning that the limit is the same as the limit of the quotient of the derivatives, so namely limit of 2x divided by e to the x. But we still have that the top goes to infinity and the bottom goes to infinity, so we have again an undetermined form. So it looks like we didn't gain anything here. However, in some sense we did gain something, because we don't have exactly the same limit, even if it's still undetermined. But it's still undetermined of a type for which we can apply the rule of de L'Hopital. So we can apply it again to that new function, to the effect that the limit is the same as the limit of the quotient of the derivatives. Derivative of the top this time is 2, derivative of the bottom is still e to the x, and now as x goes to infinity, e to the x goes to infinity, but 2 is constant, so this limit is 0. Let's do another one like that. Let's consider the limit at 0 of sine x minus x divided by x cubed. If we plug x equals 0 at the top, we get sine 0 minus 0, so we get 0, and at the bottom 0 cubed, so 0. So we have an undetermined form of the type 0 over 0. We can apply the rule of de L'Hopital. The derivative of the top is cosine x minus 1, derivative of the bottom 3x squared, and when we plug x equals 0 in the result, we get cosine 0, which is 1, minus 1, so 0 at the top, and again 0 at the bottom. So we get another undetermined form of the type 0 over 0. That means we can apply the rule of de L'Hopital to that new limit. And we get the limit at 0 of the quotient of the derivatives. Derivative of cosine x minus 1 is negative sine x, of 3x squared is 6x. If we plug x equals 0 in this, we get sine 0 at the top, so that is 0, and 6 times 0 at the bottom, so again 0. So this is again an undetermined form of the type 0 over 0. So we can apply the rule of de L'Hopital again. And we obtain again the quotient of the derivatives, limit of the quotient of the derivatives. So for the top, negative cosine x, for the bottom, just 6. And this time, when we plug x equals 0, we get cosine 0, which is 1. So we obtain negative 1/6 for the limit. And this is the limit of my original expression. Now turn to the next video to see other applications of the rule of de L'Hopital.